Hi and welcome back to my channel. This week's video is all about trying to find the area of the blue square. Now as you can see, one side of the blue square makes a chord across this circle. Now that's not necessarily the diameter of the circle, however. We've got a triangle with three corners, all the corners on the circumference of the circle, and then we've got another triangle coming off of that where AB is a tangent to the circle. Can you find the area of the blue square? If you want to solve this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, now the first thing I want to do here is to have a look at my triangles, but because I know that AB is a tangent, I know that these angles have to be the same by alternate segment theorem, okay? And that says that the angle made by or made between rather a tangent to a circle and a side of a triangle where all three corners are on the circumference like they are in this case, the angle in that segment, the minor segment, will be the same as the angle in or made by the other corner of the triangle in the major segment of the circle. So these two angles have to be equal by alternate segment theorem. We then have that angle BAF or BAE is common to both triangles ABF or BAF and triangles ABE. Okay, so that's a common angle to the smaller left-hand triangle and the larger ABE triangle, both the smaller triangles put together. Now what that means is, because those two triangles have two of the same angles in, that the third angle in both of those triangles must be the same. What that then means is, because we've got three angles that are the same in both those triangles, again, the small one to the left, ABF, and the larger one, ABE, that means that the triangles must be similar. So ABF must be a similar triangle to ABE. That means that there must be the same scale factor between corresponding sides. So I'm going to put some more labels on the sides. I want to work out AB that I've labelled X there. So I'm going to draw these out. So I've got my smaller one, which is ABF on the left, and thinking about this from the diagram, what I've kind of done really to rotate it or to transform it into this format, if you think of the point B kind of flipping down and that triangle kind of flipping over, and then I've moved it up obviously, but that's how it would end up looking like this. So the bottom left corner on that left triangle is A, top is F, bottom right would be B, and then that right hand triangle will be A at the bottom left, B at the top, and E bottom right, as you can probably tell by the angles. Now, if we label the sides we do know here, we've got two 4s on the smaller triangle, left and right, and the base of ABE has a length of 9. Now, that side I labelled X, A to B, that is the bottom of my smaller left-hand triangle, but it's also the left of my bigger triangle. Now I know, because these triangles are similar, they've got to have the same scale factor to go from corresponding sides, and to get from the base of my left one, my smaller one, to the base of my bigger one, I would need to multiply by 9 over x. Divide by x and times by 9. Now if I look at the top left, I'm going from 4 to x. So I need to times that by 9 over x again. Okay, so I need to times 4 by 9 over x to get to the x. Okay, what that gives me is this equation, and I can solve that. I can do 4 times by 9 over x gives me 36 over x is equal to x. Multiply both sides here by x, and I get 36 equals x squared, which gives x is equal to 6. Now, usually solving an equation where we've got squared, you would have the negative answer as well, but we know we can't have that because this is a length. So negative 6 is not a solution. 6 has to be the only solution here. Okay, put that on our diagram. From there, I'm going to use, I'm going to try and work out this angle. You'll see why shortly, but I'm going to try and work out this angle using the cosine rule, which is on the screen now. Okay, now I need to use my A as the side opposite my angle, which in this case would be a 4. Okay, the right hand side, or I should say really, the side BF. Okay, so I'm going to get 4 squared equals 6 squared plus 4 squared minus 2 times 4 times 6 cos theta. And that gives us this 16 plus the equals 36 plus 16 minus 48 cos theta. Cancel out my 16s. 36 minus 48 cos theta equals 0. Add 48 cos theta to both sides. Divide by the 48 and I get cos theta is equal to 3/4. Now, I don't need to find the angle here because what I need in a second is just cos theta. So I'm going to put that to one side for now and save that for later. And now what I'm then going to do is I'm going to be looking at my bigger triangle ABE, and I'm going to work out BE squared, and I'm going to again use the cosine rule for that. So BE squared is equal to 6 squared plus 9 squared minus 2 lots of 6 times 9 times by cos theta again. Now I can calculate some of those values and I can substitute in for cos theta and I get this. So BE squared is equal to 36 plus 81 minus 108 times 3/4. And actually BE squared is going to be the area of the square. So I don't need to do anything else once I've calculated this answer. And it is 36 centimeters squared, which is a pretty neat answer, I think. If you were able to get that answer, if you were able to solve this problem in a different way, please let me know down in the comments below. If I made a mistake, please let me know down in the comments below. People that got to this video early will have probably seen that I did make a notational error, so I've corrected that now. But yeah, if I make any mistakes, let me know. If you found a different solution, let me know. If you enjoyed this video, drop a like on the video, I really appreciate it. And if you haven't already, please do consider subscribing to the channel. We're nearly at 950, which is very, very close to 1,000. So if we get to 1,000, I'll be very, very grateful. And I'm very happy that we have got the amount of subscribers we have and that people watch my videos and seemingly enjoy them, which is very good. So yeah, if you haven't already, like and subscribe. Thank you for watching. Have a great week, everybody, and I will see you next week for another problem solving video. Till then, bye-bye.